Okay, so let's do a quick example, or examples. Let's do phosphorus and cobalt here. Phosphorus has got 15 electrons and cobalt's got 27. So what we're going to do is just find a home for all 15 electrons, or we can pretend that there are 15 people trying to get into the theater. So let's start with 15. We're going to keep track. Now we're going to do the electron configuration on the left, the summary, and the orbital diagram or notation on the right. This is the actual arrows and pictures and all that. So first thing, 15 electrons out there, 15 people out there. The first two come in, and they're going to sit in the first energy level in the seat that's round, the 1s seat. And two people can fit there because all seats, all orbitals, are made for two. So I'm going to summarize this. 1s contains 2. 15, now down to 13. Then I'm going to put two people in the 2s seat. Enter row 2. All we see is the S seat over here. We'll fill that first. Then we'll worry about the 2 P seats. And we know that there's 3 of those P seats. We'll worry about them next. So now we're down to 11 electrons. So I go over to my 2P and I realize that I can fit 6 people here because there's 3 seats. Each seat holds 2. But I do have to fill it with arrows going up, up, up first. Then I do down, down, down. So now 2p is filled with 6, so I summarize. 2p, 6. Now I'm down to 5 electrons. Well, the first energy level is filled, the second energy level is filled, so now I move on to the third energy level, or the third row. And the first type of seat I come across is my S seat, which can hold 2. So I can summarize, 3s2. Now I'm down to 3 electrons. 3 electrons, 3 people walk in, and they look in that third row, and they see those 3p seats. But because these guys are all negative, they repel each other, we're not going to force them to double up and sit together. We're going to allow them to spread out. And we're going to note that with up arrows, 1 in each of these 3 orbitals. That's Hund's rule. Put 1 in each before you double up. Now in this case, we don't need to double up because we only had 3 electrons left. So we're just going to summarize here. 3p3. I know it should be 6. It should fill with 6, but it's only got 3, so that's what I write. I only put what it has in there at the moment. Now you might look at this and say, well, what's wrong with phosphorus? Why doesn't it have 1, 2, 3 more there? It needs 3 more. And you just kind of figured out what phosphorus is going to do. Phosphorus starts with 15 protons and 15 electrons, and it's not really happy that way. It's going to go get 1, 2, 3 more. This is going to become 18 electrons. And suddenly, 15 is not equal to 18. It's not an atom. We don't call it an atom anymore. Now we call it an ion. And it's going to gain 3 electrons, so that means it's a -3 charge. So we're going to see over time that the orbital diagram makes it really easy for us to figure out what an atom's going to do to become more stable or to become an ion. So we summarize 3p3 over here. We know it should be 6, so we know that it needs to get 3 more negatives. So it's going to end up with a -3 charge. This is a little more obvious than this, but they still both kind of give us the same information. All right, let's look at cobalt now. Cobalt's got 27 electrons, so we're going to try to keep track of 27 electrons. So I'm going to write really small here. And I'm actually going to do it like this. I'm going to put the 2 on top of each other just to save space. So the first thing I do is draw my 1s, and I label it. 1s, put my 2 electrons in there. Now for my electron configuration, I write 1s2. Now I'm down to 25. Then we walk into the second row of the theater. We come across the S seat. We put 2 there. We summarize. Oops. 2s2. Now I'm down to 23. The next thing I see when I look in that theater is in the second row, there's 3p orbitals, 3p seats for 2 each. So I'm going to put 1 up, 1 up, 1 up, then I go down, 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 down. Summarize, 2p6. Now I'm down to 17. Now the first energy level's filled. Second energy level has S and P, that's filled. We have to move on to the third energy level. 3s, it's going to hold 2. So I summarize, 3s2. Now I'm down to 15. I got 15 more people to go, so I look down the third row and I see the 3p seats. There's always 3 of them. If you're in the P section, there's always 3 seats. So I put 1 up, 1 up, 1 up, then I do down, down, down. There's 6. I am now down to 9. So I summarize 3p6. Now, you might think 3D comes next. 3S, 3P, 3D, but that's not the case. Remember, the 3D seat was a little more expensive than the 4S. There's some weird stuff going on there. The 4S seat was a little bit cheaper and a little bit closer to the theater than the 3D. So I'm going to put 2 electrons in the 4S. The S's always fill before the D's. Now I'm down to 7. Now I get to 3D. And no matter how many electrons I put in here, D always has 5 options, 5 seats. So I always draw 5 lines, even if I'm only putting one tiny little electron in there. Now I'm going to actually put all 7, because it can hold 10. There's 5 seats times 2 each. That's a grand total of 10, but I only need 7 spaces. So watch what I do. 1 up, 1 up, 1 up, 1 up, 1 up. There's 5, 6, 7. I only double up 2 because that's what I have to do after there's 1 in each. But I don't do this. 1, 2, 3, 4, 5. I don't double up, double up, double up, and then 1, and leave an empty seat. These guys are all negative. They don't like each other. They don't want to double up unless they have to. That's Hund's rule. They don't double up until they have to. So to summarize here, I write 3D7. And I used up all my electrons. And if you kind of want to think about Cobalt's predicament here, Cobalt also is missing 1, 2, 3. So Cobalt might gain 3 more and also end up with a -3 charge. So again, this shows us kind of what the situation is, what's missing, and then what is Cobalt going to do about it. But we'll talk about that when we talk about ions at a later date. Right now, you should just be able to draw electron configurations or orbital notations or orbital diagrams, and you should be able to, right now, keep track of your electrons. A little while, we'll show you how to use a periodic table to help you through this process. But just keep track of your electrons and make sure that when you're done and you add up your coefficients, you add up your superscripts, they all equal the number of electrons that you started with. Or if you count all your arrows, they equal the number of electrons that you started with.